Hello, and welcome to, I think this is our last panel of the day. We're going to be talking about examining the mobility trends of the next decade. I'm Sam Abuelsamid, Principal Analyst with Guidehouse Insights, and we're the market research arm of Guidehouse Consulting. And let's kick it off here with a little bit of an introduction. It's good to be back on a live stage in front of real people instead of staring into a webcam. And let's see. There we go. Oops. All right. So, as you all know, 2018 will be the year of the autonomous car, or at least that's what we were told back in 2015, 2016, when Travis Kalanick was sitting on a stage somewhere or in an interview saying that autonomous cars were going to be an existential threat to Uber. Okay, maybe it was going to be 2019 when Cruise is going to launch their commercial service in San Francisco, or perhaps 2020. Over those years, VCs in Silicon Valley and elsewhere poured billions of dollars into autonomous vehicle development, as did OEMs and suppliers. As you know, they're still not here. It turns out that it really is a hard problem, as self-proclaimed genius recently revealed on Twitter. But they are going to come, I think. I do believe that we will get automated vehicles in significant volumes, but the timeline for reaching that point is going to be a little bit further out into the future. Sometime probably closer to the latter part of the decade. We're starting to see them now. There's some out there. Waymo's doing some very limited deployment of fully driverless robo-taxis in Arizona. Next year, we're going to see more. In fact, even later this year, we're going to start to see some more pilots. Next year, that's going to grow and continue to grow. And we're also going to see a lot more use of these vehicles for deliveries, for goods delivery. That's, in fact, I think through much of this decade, that's probably actually going to be the dominant mode for light-duty automated vehicles. And only very limited numbers of consumer vehicles. We're projecting about 180,000 level 4 vehicles deployed globally in the middle of the decade, maybe 14 million or so by the end of the decade, and the majority of those are going to be in China. But it's not all bad news. What we've been seeing over the last couple of years is as the timeline for those highly automated vehicles slips out further and further into the future, we're getting a lot of the technology developments, a lot of the lessons that were learned are starting to filter back down into ADAS systems. And between the suppliers creating these technologies and the automakers that are deploying them, they want to start getting some return on that massive investment they've had. And so we're starting to see technologies like imaging radar, LiDAR, coming to level 2, level 3 systems, and even level 1 systems where vehicles are still really driver assist. They're not even hands-off systems. We're going to start to see some of these technologies deployed in an attempt to improve the capability of things like automatic emergency braking. The other big thing that we're going to see this year, in addition to connectivity, or this decade, is electrification. It's the time when we're starting to get electrification really taking off. By the end of next year, we expect to have nearly 40 new EVs on the market here in the US alone. By mid-decade, over 300 EV nameplates globally. And legacy automakers, particularly over the last 9-12 months, have really started to aggressively pivot to going more into EVs. We've seen companies like General Motors say that by mid-2030s, they want to be 100% EV. Ford has said they want to be selling 40% of all their global sales as battery electric vehicles by the end of the decade. Others like Volvo are aiming for 2026 to be all electric, and certain other premium brands like Jaguar as well. And as electrification takes off, we're projecting about somewhere around 30% of all new vehicle sales globally to be electric by the end of the decade. And battery electric vehicles are going to dominate over plug-in hybrids. As batteries have become more capable and lower cost, the case for plug-in hybrids is going to shrink more and more. And by the end of the decade, we expect to see about a 6-to-1 ratio of battery electrics to plug-in hybrids. The other thing, of course, that we're going to need is charging infrastructure to support all those EVs. We need about 55 million charger sales by 2030 globally to support the deployment of all these EVs. So I'm going to hand it off now to Reuben Sarkar from the American Center for Mobility. Reuben, take it away.
With the American Center for Mobility, we are an advanced proving ground, and early in my career, the best days were always the days you can get out from behind your desk to a test track. So more appropriately, I would refer to us as a smart mobility test center. We were designed for the testing and validation of advanced mobility technologies, primarily and initially for connected and autonomous vehicles. But we also do a lot of work in advanced driver assistance systems, electrification, primarily on the charging side, and on the grid side, as well as other mobility technologies. We are a 500-acre test track comprised of railroad systems, so a little different than the tracks you see here where they're nicely paved. We actually like to replicate the kinds of roads you're going to see in the real world so you can test the sensing and perceiving of your vehicles. Layered in on top of the road infrastructure as an ITS network infrastructure, so cellular as well as V2X. And then specialized test equipment that you can use for the testing and validation of connected and autonomous vehicles. We are a public-private partnership, but we are open to the public for testing. And we consist of a number of different kind of specialized test environments that can uniquely challenge connected and autonomous vehicles, as well as other advanced safety systems. And so we're not a market research firm, but we get our insights based on the testing and validation that we do. We're the tip of the spear, so to speak, in terms of what people are testing, in many cases just before they go out into the commercial world. And as you heard earlier, since there has been a slight tempering of the expectations on when fully autonomous vehicles are going to be in the market, we have seen a very large shift over to ADAS testing for the passenger car space or consumer applications for the passenger car space. We do primarily testing against NCAP standards, Euro NCAP, NCAP, China NCAP, which set the standard levels of testing for demonstrating ADAS performance. We see testing all the way from warning systems or level 0 all the way up into traffic jam assist systems. One thing we do see as a trend is that companies are going beyond the standard NCAP testing to actually test vision systems, and primarily vision systems, beyond the standard ideal test conditions, so probing more edge cases in terms of what vision systems can do on cars. With regards to AV testing, it's a little more complicated because standards are not readily available, so it's hard to actually say which tests are being run to test which specific systems. And in a lot of cases, what we do is very confidential to the customer, so we don't always know what they're doing. It tends to be more specialized regarding the specific operating design domains that they plan to deploy with. But what we can say is, which sections of the track are being used, and then from that we can infer the kinds of work that are being done. And so today at ACM, we see predominantly our high-speed areas being used. Our highway ramps, off and on ramps, as well as our urban arterial, those are essentially booked solid in terms of people testing in high-speed environments. We see a lot less work in low-speed environments for passenger car, but we are seeing an uptick in the area of low-speed shuttles or purpose-designed vehicles for low speed. I'm going to talk a little bit about parking later on and smart parking features as a subset of automation. And then on connectivity, you may have heard some of the earlier conversations. We're just now getting to the point of seeing 5G getting implemented and people talking about doing more C-V2X testing. We ourselves don't see a lot in the urban and residential area. That also may be because our major differentiator is the high-speed areas. But there is continued work by AV developers to get to level 4 going forward. So if I just do a side-by-side of the advanced driver assistance systems, level 0 through level 2, alongside automated driving systems, level 3 through 5. As I already mentioned, we see a heavy emphasis on the focus for level 2. We often hear the word level 2 plus thrown about, and I'll just be clear, it's not an industry standard definition, but I think what people are trying to convey is that they want to take things all the way to the level, just to the edge of level 3, but still require that the driver be engaged in driving the vehicle. So it might be more of a distinction to keep the driver in control. We are seeing some level 3 systems coming out into the market, and in those cases, all of them are likely to require a driver monitoring system. There was actually a debate as to whether you would even see level 3 in the market because the challenges of getting drivers to re-engage when they need to. With regards to level 4, we see more of the adoption, as you already saw in the earlier slides, in fleet applications and in commercial vehicle applications happening in the next, say, 5 years, maybe some large deployments. And I put the tipping point for level 5 at 2030. I don't believe it's going to be 2030. It's after 2030. It could be 10, 15, 20 years before the day you have no steering wheel and the car, takes you to any environment. I'm not trying to redefine SAE J3016. Please always refer to them for the proper terminology. I'm just simplifying it for sake of discussion. And then alongside automation, I mean, there's an increasing focus on driver distraction. Accidents in general are up despite driving less. Teen distracted driving has become a major issue. And in general, we're seeing a lot of legislation and discussions around distracted driving. So, it also has its applications for automation, but we're going to see a lot more of driver monitoring systems coming into the market, particularly in companies trying to deploy level 3 type automation. It's almost a prerequisite. And then augmented reality and head-up displays. Head-up display technologies have come a long way. While we don't specifically test at ACM as much head-up displays, we do a lot of work with augmented reality. This is seen as an enabler both for providing better engagement of the driver and more information, but also a transition to higher degrees of automation where even if you're not driving, you can see what the car is doing and it gives you a better sense of comfort and confidence in what the technology is doing. So level 4, anything less than level 4 requires full driver's attention. And then with regards to smart parking, I mean, we all know that parking is something that we don't necessarily enjoy doing. At any point in time, 12% of drivers are looking for a parking spot. And we envision that there's going to be a widespread use of smart parking technologies coming into the marketplace, not just automated valet parking, but anything designed around making your parking experience better. You may have heard the news that ACM was selected to operate the Detroit Smart Parking Lab, which is like a demonstration facility for these kinds of technologies in partnership with Bosch, MEDC, Bedrock, and Ford, who are the sponsor partners for that. But we envision that to be fairly widespread by 2025. And then lastly, connectivity. The ultimate end game for autonomous vehicles is also what's referred to as cooperative driving automation. Some would say that that's the holy grail because the cars talk to each other in the infrastructure while they also have the benefits of sensing, perceiving, and their own AI. But there's a question as to whether you need both to concurrently be deployed or have connectivity out in front of autonomy. I think what you're going to see is a parallel deployment of autonomous vehicles that are increasingly going to rely on connectivity, but they're not going to have it as a prerequisite. As I mentioned, 5G is just now coming into the market, CV to X following the FCC's recent ruling. And so places like ACM are putting in infrastructure for that sort of testing. We anticipate not only 5G and CV to X, but a lot of work done in edge compute, which you may have heard in some of the earlier talks in the session just prior to ours. And with that, I will hand it off to the next speaker.
Thank you, Reuben. Next up, we've got Mike Dovorany from Escalent.
Thanks, Sam, and thanks, everybody. What I'm going to speak through today are results that we have basically from talking with thousands of consumers related to their opinion of electric vehicles. So for any of you who haven't heard of Escalent, the firm that I work for, basically we are a human behavior and analytics firm. So we work with companies to understand human behavior and turn that into strategies that can be successful. And basically, that tends to mean that we're working with companies that are facing disruption. So that's been automotive for the last at least 10 years now, and looks to be so for the future. So in this work, we work with companies across all kinds of industries. I represent our automotive group, and we work with almost all global OEMs with this work. So essentially, one of the things we find with all the work that we do with consumers is that when we look at electric vehicles, we're really attracting different consumers to electric vehicles. It's not the people who've been buying EVs in the past. It's an entirely different buyer. And we've started to see that over the last couple of years. As you get different vehicles that come to the marketplace, they're really attracting different people. And an example here, we've got the Ford F-150 Lightning. And essentially, with all these, if you listen to Bloomberg New Energy Finance, hundreds of vehicles coming, to us it's about, okay, you have to get the opinion from the right consumers because otherwise you're trying to build your strategies based on a foundation that's not sound. So who do you talk to? So why don't you talk to electric vehicle owners, right? Shouldn't they have all the answers? They already bought EVs. And I mean, if we just keep that example of the F-150 Lightning and you look at these, these two gentlemen here, are these really, do they look to you like the buyer of an F-150 Lightning? You know, the answer is no, they don't. If you talk to either of them because they're EV owners, you're talking to the wrong person. You have to make sure you're talking to the right people. An evolution that has happened in research has been, well, talk to hand raisers. You know, they basically self-select, they hand raise and say, I'm interested in EVs. One of the biggest problems is that that's a really narrow group of people that's not representative of the market. So basically, so far, most EV owners have been pretty well informed, pretty self-actualized. But as we look at the new EVs that are coming to market and who they're attracting, these are people who generally haven't done any research. They don't know enough about the vehicle unless they're actually shopping to actually raise their hand. So we can't rely on talking to hand raisers. So what we do, and the results I'm going to talk through in just a moment, we have a program called EV Forward, where essentially we basically put people through a personality test. We look at about 600 different factors from each person, and from that we're able to identify who the EV intenders are. And essentially it goes across the whole spectrum. So these EV intenders, these are people who are going to be buying vehicles in the next 5 years. How many of them are out there? How many exist? So we've been doing this work for a couple of years now. So in 2021, about 18% of new car buyers are what we categorize as EV intenders. So these are people that next time they shop for a car are going to seriously consider an EV. That's actually up a little bit from the previous year. We also have two other categories. One we call EV open, which is essentially people who are open to the concept of an EV, but they're not really likely to actually shop it next time. And then EV resistant, which is the biggest group, though it is shrinking slightly, which is essentially, that's people who is, you know, right now, they really don't want to have a conversation about EV. It's not really something that's on their radar. There's an important point to make about this. When you talk about EV owners today, and then you look at it compared to the size of EV intenders, there's about 6 times more people who fall into that group of EV intenders. So it's a relatively large group of people, but you have to know who they are to talk to them, but they have some interesting insights when you do talk to them. So one of the biggest things we find with these EV intenders is why, okay, if you're somewhat interested in cars, why haven't you purchased yet? And so when you look at EV intenders, the single most important segment defined by IHS that they want to buy vehicles in is midsize SUV. So there are so many midsize SUVs right now on the market powered by internal combustion engine vehicles, we couldn't even fit them all on one slide. So these are how many choices these EV intenders have in the segment that's most important to them if they want to buy a gasoline vehicle. This compares to the number of choices they have today if they want a battery electric vehicle. They have 1. So ultimately, that is the biggest barrier we're finding with these EV intenders, is that even if they're interested, the product in the marketplace that would speak to them or that would work for them doesn't exist yet. So it's great that all those vehicles are coming, but it's a valid question, are they coming fast enough to address this concern? The other thing I want to point out is, we always see cost, range, charging speed, warranty. These are kind of big issues with EVs. And we all know about them, right? Range anxiety. We have to get cost parity with internal combustion engine vehicles. But I want to point out for EV intenders, actually, we need to change that narrative. It switches. Charging speed is actually more important for EV intenders than these other factors. They over-index on that. So it's not to say that range and cost aren't important, but one thing that we need to point out is with these next EV buyers, it's not about driving down cost. If you put a more attractive product in front of them, they'll actually buy it. But so far, that hasn't really existed. All right, thank you. I'll pass it on to the next speaker.
Thanks, Mike. Next up, we've got Phil Reich from Google.
Hello, everybody. Yeah, there we go. So my name is Phil Reich. I am from Google. I'm part of our strategic partnerships team working for automotive. So we work with all the different OEMs. We work across the dealerships. We work with the tier 1 suppliers and really try and think through what is the future of automotive and how can Google help with that. So today, when I thought about that topic, I just wanted to bring some broader ideas that we can think about that all the OEMs, as we look at what's out here today, are definitely thinking about as well. So talk a little bit about smarter manufacturing, the growing customer expectations, new revenue streams, and vehicle to everything. So from a smarter manufacturing standpoint, we are going to see more and more factories running using data technology and specifically AI ML. We're starting to see the shift, but it's going to happen even more. And the ability is going to allow us to do things faster, quicker, smarter, with less mistakes and less inefficiencies. Also, the supply chain has gotten whack over the past couple of years. So we're going to see a shift in how we find the different parts that we need. We're going to see a lot of OEMs investing in new ways of getting the materials that they need and going deeper into their supply chain. So relying less on tier one suppliers and really kind of building it for themselves because they need to. And the last piece around manufacturing is thinking about how they're going to seamlessly connect the vehicles that want to be connected to the rest of the world. So more and more sensors on cars, the ability to put those in the cars at a price point that is reasonable to be able to sell them. Moving on to the customer. Customer is key. They are going to expect more and more from their vehicles. So first and foremost, they want to have a customized experience. They want it to be personalized to them from when they look at the car, buy the car, to when they use the car. They want different users to have different experiences in the same car because they're going to be sharing it among their family, among friends, potentially among strangers. So that experience is going to be incredibly important and needs to be personalized. They're also going to see, we're going to see a shift in vehicle not just being a car, but it being an actual device. So how is that going to fit seamlessly into our lives? We want to be able to go from home to car to work to the store, and everything just works seamlessly together and not have to think about where I am or what I'm doing. All of my technology works together, and that's the expectation they're going to have of the OEMs. And then finally, the vehicle isn't for just getting from point A to point B safely. It's going to have to be so much more. It's going to be a place where we have entertainment. It's going to be a place where we transport not just ourselves, but our things. And we're going to need to meet those expectations and bring those to our customers. From an opportunity standpoint, there are a ton of new revenue streams coming, and whichever OEMs can really capitalize on this are going to make a killing in this area. First of all, entertainment. So as past speakers have talked about, we're moving towards autonomous. We can't wait until we're here for autonomous to be thinking about this. People are going to be spending more and more time in their car where we will have eyes that are wanting entertainment, that are there to be marketed to. So we need to start thinking through the solutions that are going to allow us to bring those experiences to the customers and monetize it. Next, we see our vehicles becoming a credit card. Whether it's over-the-air updates or online shopping or even going through a drive-through. Why should you have to pull out your phone, pull out your credit card? Your vehicle could be your credit card. Pull up to the drive-through and go right through. And then lastly, the role of the dealer has been shifting, especially during COVID. We've seen so many people move to e-commerce, but we see that shifting even more. If the dealers really want to be more than just a once a year or once I need a new car stop, they really need to think about how they're going to use the space that they have to be able to bring more opportunities to the customers. So whether that's using fleet management there to be able to charge your EV vehicles from your fleet, really thinking through what the role is going to be. And then lastly, vehicle to everything. So a bunch of us have talked about that today. At the beginning, thinking about vehicle to infrastructure, all those sensors we're putting in the car need to speak together. So OEMs are going to have to focus on where they want to bring that technology and what of that is most important to making it work for autonomous. The next thing that's a huge opportunity is thinking about, as we move to more and more EVs, where that energy is going. So how are we going to move that energy back to the smart grid through our homes, through our cars? It's a great opportunity to think about what industries we want to work with. And then lastly, vehicle to vehicle. Once we have federated learning between these cars, you can see ahead of time what's going to happen in 2 miles from now, and that can help cars behind us figure out a better way to inform better driving decisions.
So lots of changes coming to the industry, really thinking through how each of these will impact and could be a great opportunity for the OEMs is something we'd love to do with them. So thank you so much.
Thank you, Phil. And finally, we have Tarik Bolat, the CEO of GPR, formerly known as WaveSense.
We've got a video first.
As the automotive and trucking industries drive toward a future promising new and improved advanced driver assist features and autonomous driving, vehicle positioning technology must evolve in order to deliver the safety and performance drivers demand, anywhere and in any condition. When other positioning technologies fall short, GPS struggles without direct line of sight to satellites, for example, cameras depend on clear lane markings, and LiDAR struggles in visually uniform environments or even when the sensor becomes obscured. Both safety and performance are compromised. That's why we created GPR. Using ground positioning radar, GPR maps the substructure beneath the road. That substructure is completely unique, like a fingerprint, and allows GPR-equipped vehicles traveling over mapped areas to find their position quickly and with exceptional precision and reliability, regardless of road conditions, line of sight to the sky, or sensor cleanliness. Whether it's on-road in challenging conditions like unmarked roads, poor weather, or urban canyons, off-road, or even underground, vehicles that incorporate GPR are able to deliver a more robust, higher quality assisted and autonomous driving experience when other sensors can't. GPR, safeguarding the automated driving experience.
Hey folks, my name is Tarik Bolat, as you just heard, co-founder and CEO of GPR. I'll try not to repeat anything that's in the video because I know we're running short on time here. So let's jump right in. Okay, first it's important to understand what we're talking about when we talk about positioning. It's an input to navigation. How does the car know where it is and where it needs to go when it's acting autonomously or when it's informing the driver? And you can see very simply why that's important here. If I think I'm 3 meters or a meter to the right of where I actually am, I'm going to collide with the guardrail in this example here. Whereas if I have an accurate position, then I'm going to be able to sail through these types of curves. And that's something that's true regardless of what type of road you're on, as long as you're trying to provide an autonomous experience for the driver. As we just heard, there are major gaps in today's positioning technology. So whether it's GPS being blocked or having multipath issues, weather obscuring sensors, or a lack of unique surface features, so a visually uniform environment in a parking garage is a great example. All of those are gaps in today's technology that need to be solved before we can have really robust L2 systems, as well as full-up autonomous driving. Similarly, LiDAR, camera, and forward-facing radar look at the same set of objects on the road, and so they're obscured by a similar set of phenomenon. If there's snow, for instance, that's going to obscure a camera and a LiDAR. If there's a truck blocking the way, that's going to obscure camera, LiDAR, and radar, just as an example. And so what we've done is create a way to image the subsurface, going about 10 feet into the ground with a specially designed radar, getting reflections off of things like changes in soil type or soil density, roots, rocks, cavities, utility infrastructure. That gives you a unique fingerprint that is static regardless of what is going on the surface. It allows you to generate your position the next time you drive through. And hitting on some of the themes that you've heard from the other speakers today, that's really complementing and enabling some of the key trends in mobility. So big shift towards ADAS systems, L2+, whether that's on the highway, in the city, or in the parking garage. Positioning being a required aspect of that, and the current stack not necessarily being up to the task that the automakers are looking for. And so the features that we're working on today with OEMs are things like autonomous lane keeping when lane markings, aren't present, autonomous valet parking, so instead of taking a shuttle here, you could have driven up to Motorbella, car would have parked itself and come pick you up when you're ready to roll. And then some off-road features for some of the high-volume SUV and pickup platforms here in North America. We are currently working with one of the top 5 automakers on a pilot targeting series production in 2026. It's a very large program targeting a set of platforms within this OEM, looking at things like parking and on-highway lane assist as well. When we think about why this is a transformative technology that's really breaking through, it's low power and low cost, like other radar. There are no mechanical parts. For the vehicle designers in the room, it doesn't have any aesthetic impacts. It's packaged underneath the vehicle, and the architecture is scalable. And so what that means is that it's well suited to scale with our automotive partners as they look to build towards series production. We're tackling the ADAS market, we're tackling the AV market as well, obviously lower volume right now as Sam and company alluded to. But we're also going after some industrial applications, things like construction, mining, rail, all these other vehicles that require autonomous systems today and require a reliable positioning input but can't find it with the current stack. With that, let me close it off and look forward to discussing with the rest of my colleagues here.
Thank you, Tarik. All right, so let's get into a discussion here. So the common thread through all of what we've heard here from automation, electrification, sensing is data. Whether it's data that's being used in the vehicle or data that's being shared to the infrastructure or between vehicles and vulnerable road users. We're generating so much of this data on and off the vehicles, but do you think our networks are robust enough to handle it all? And I'd like each of you to chime in on this, both in terms of things like carrier networks, V2V, V2X networks, in factory networks. Let's hear from each of you. Reuben?
All right, now you can hear me. Okay, so I think that for most people who work with these technologies, they'll realize that they produce petabytes of data from fleets and terabytes a day. You can fill a laptop in like 2 minutes, right, with some of these tech. So you need a lot of capacity to get that data off. And I would say that the existing infrastructure today is not adequate. Even in the development of these vehicles, most people have to actually take the data. We at ACM offer up to 100 gigabit per second internet speeds, which are orders of magnitude faster than you get in any other, your home internet, 200 megabits per second. And that's still not adequate enough. So I think there is an issue in terms of technologies that are going to be able to move that amount of data, or more importantly, decide what data to keep, decide what data to process locally, send to the edge for processing, and then send to the cloud. Because even with 5G, it's fast, but it's not nearly as fast as fiber optics, and that's not fast enough. So you got to be able to manage the data locally on the edge, or what they call the fog, and then in the cloud. And there's more work that's required to develop those strategies.
Mike?
Yeah, I mean, I think that's a great point. I would add to it, from the work we do with consumers, there's a lot of concern, or increasing amount of concern, around the amount of this data that's generated. So it is interesting to the extent, we need to process this massive amounts of data, and we're dealing structurally with how we actually process it all. And at the same time, there is this, increasing layer of complication on it of, well, how do we handle that data? Are consumers going to be okay sharing it, or do we have things like what's happening in Europe where there's greater restrictions on how it's used? So it's something that we continue to monitor, but it's kind of an additional wrinkle on top of all this.
Yeah, kind of building on both those points. So I think what will be key is determining what needs to be actually computed in real time, or needs to go up to the cloud to be computed. So the edge node is going to be incredibly important. And then in terms of privacy, absolutely. Like, vehicle owners are not going to want to give their data to everybody. And the OEMs are going to have to realize what is needed and what is not. All data is not needed to be able to do what they need to do. So figuring that out is going to be incredibly important.
Yeah, just wrapping up there, the distinction of what's local and what's the rate between the cloud and the vehicle is an important one. I think that there's a lot of the innovation in automotive is actually going to be around things like feature extraction, compression. How do you actually build these data sets in ways that are actionable, but still light enough of a footprint that can go back and forth. And also just really building out what's on the vehicle. We're firm believers at GPR that almost anything you're going to want to use is going to be stored locally. And so, the model that we think about is you're driving around, you're typically really pulling on local drives, and then you might plug into Wi-Fi when you go home, or if you really need an over-the-air update on 5G, you can do that. But nothing will be really safety critical that's happening in that way.
Mike, to follow up on this, one of the things that I think both you and particularly Phil mentioned was the opportunity for new revenue streams based on some of this data. From your experience talking to consumers, the kind of surveys that you do you see, where do you see the acceptance of some of these types of things that manufacturers want to do to generate new revenue streams based on the data?
Yeah, I mean, I think the bar is relatively high. I mean, one of the things that we're seeing is that an incremental approach to, well, hey, I'm the auto manufacturer, I've maybe got better control of a value stream, therefore I think I'm going to capture it, is that from a consumer standpoint, unless you bring additional value, that's not a value stream you can capture. So just because you think you can capture it, if the consumers aren't willing to pay for it, I mean, it's really getting them to pay for it. So that's a super important part of it. The one thing that I would say that we're seeing as well is that it's not about necessarily looking at the value streams that exist in the vehicles today, because increasingly when we talk to consumers about what the future of the vehicle wants to look like, it's about, in many ways, kind of throwing out aspects of the current in-vehicle experience and coming up with something that really works more seamlessly, is better integrated. So I think that there's, it sort of requires, if it's going to be done well, shaking up how we look at value streams that exist in a vehicle today and anticipating some of these newer ones that are going to come.
Yeah, I think customers are willing to let you use their data if it's something that's going to be helpful for them, right? If it's going to help their experience, if it's going to make it better. So thinking about that, if a car company was going to use data to be able to tell me, hey, you're going to need an oil change in X number of miles, or hey, we see these different things going wrong with your car, like maybe you pull in here and get something fixed, I think that's something that users would want. So really thinking about, again, where the value is in the data that you're giving, and making sure that you're giving the value back to the user for using their data.
So, during the previous panel, one of the things that was mentioned was the availability of chargers. Ford, for example, through the Ford Pass network, they're claiming 63,000 chargers that are on there, so you can easily pay for charging. But one of the challenges that the customers are experiencing is when they get to those chargers, sometimes they're not working. You talked, Phil, about in manufacturing. Talk a little bit more about how that data, how telemetry can be used to try to improve the robustness of various aspects of the mobility ecosystem, from charging, deployment of AVs, and also at the manufacturing level.
I think really data is the key to making it happen, because we can't solve every problem all the time. We're not going to have every EV charger working all the time, but if you can figure out where the most important EV chargers to fix at any given point are, using the data, that's going to help the ecosystem be better. So I think just using the smart technology that we have to digest all the data that's coming in, this public data, is going to help us make the whole ecosystem more robust.
Sam, one thing I would add on that is we have found that one of the most important aspects, there's a lot of discussion about, we need more chargers to get out there, and there's all the work we do suggests, we do need more charging infrastructure. That said, some of the more recent research we've done has shown the importance of charging speed really being more important than charger location. And so to the extent we have chargers that are, if you're doing a drive and you could stop at multiple places, but one or two of those places are going to offer you a significantly faster charge, consumers overwhelmingly want that. And so for us, it's not just knowing when chargers work or don't, or if they're online or where they are, but also what is the charge speed, and how can I minimize the disruption to my life as part of that.
So it sounds like it's not just having a pin on a map to show you where the charger is, but also being able to incorporate it into your trip to have the least amount of disruption, the least friction.
Exactly.
So, Tarik, some of the work that you're doing at GPR, one of the challenges that we need, that we've got as we move into this new era of mobility is mapping. and a key part of what you're doing is creating those maps, and then of course using the same technology to figure out where that vehicle is in physical space on that map. Can you talk a little bit more about what can be done in terms of keeping maps fresh and up to date, and how what GPR is doing can fit into that?
Yeah, it's a great question. So map that you're using reflecting the actual reality around you is incredibly important to a high fidelity experience. And so there are a couple of ways to do that. One is that you can work with data that is static over long time periods. That's what we do at GPR. Subsurface doesn't change for years-long periods in some cases. Or if you're working with above ground data, you've got to figure out a way to constantly refresh that. And so there's some distributed models, which are, you put a camera on every vehicle and you try to process it that way. Obviously, that requires a lot of back and forth between the cloud and verification with just the sensors that are on the vehicle. Other folks have mapping vehicles just going around at a regular rate. All of that's very, very expensive. And so I think we're going to have to find the balance in terms of what are the economics that work to create a map that's stable over long time periods, or that is always going to be right. That's part of the attraction of GPR to the OEMs that we're working with, is saying, hey, you don't actually have to go and send a fleet to update this all the time, or you don't have to have a low confidence in your environment because you haven't mapped something for 2 months. But certainly it's a big challenge, and I think standardization of sort of map format is going to help that as well.
Reuben, at ACM you've got a wide variety of different companies using the facilities. How does that work out? Do you see any cooperation among the companies? Are they using the facility to do interoperability testing, or is everybody basically just coming in and doing their own thing in secret?
Yeah, I mean, it was always envisioned that interoperability testing would be done at ACM, and I think that's yet to come. What we see right now are a lot of individual companies doing their own testing. In many cases, things are just ramping up right now, and they do it in high degree of secrecy. So it's always challenging when you have a shared use test facility and competitors are co-located there. How do they test separately? But we're able to kind of manage that across our test environment, so they have that high degree of secrecy. There are some collaborations out there. We've had consortia come in that are doing smart cities related work. They use our facility across a number of companies, including competitors, to test and validate, and then they go into city environments and then do the deployment. So, but by and large, it's highly competitive. We don't see a lot of collaboration across companies right now. They're doing their own thing.
Speaking of smart cities, this is one of the areas where there's been a lot of discussion, a lot of work over the last several years, and one of the keys to that is understanding, for cities to understand what's going on in their environment. What kind of use is there of the infrastructure, the roads that they've got? What sorts of things are being done at ACM with regard to that?
Well, I mean, we tend to not do our own independent type validation, right? We're a facility that others come and use. And so it's usually, as I mentioned, these consortium that come in. They'll leverage, for example, our road systems, our intelligent transportation network, our connected to the traffic signals. They'll do, various intersection management. We do research in terms of, V2X communications with intersections to try to navigate safely, and sometimes in cases in unstructured intersections. But again, we ourselves don't necessarily do the testing ourselves. If we're hired to do it, we'll do it, but we usually keep that confidential. So I can't always comment specifically about who's doing what. That's one of the challenges we have, is we sit on top of all this work, and yet it's done under a high degree of confidentiality. And so I'm not sure I'm answering your question directly, other than there are consortia there that are using our track to generate that sort of data and using that in real-world environments. For example, down in Tampa right now, there is a smart city effort down there with a number of companies that use our facility to then deploy in the city level.
Okay. I want to pivot a little bit to software. Obviously, it takes a lot of software and compute to handle all this data. Another interesting trend we've seen over the past year or so is a lot of automakers wanting to take more direct control of the software. Traditionally, certainly over the last several decades, they've relied heavily on suppliers to bring software for the various features, and they're shifting now to wanting to take more direct control of both integrating and even developing that software. Phil, how's that working with Google? How does Google play into that?
So I think we see that trend for sure, and I think what's going to need to happen for the OEMs to be successful there is a mind shift in how they think about the car, right? It's almost like moving from making hardware to making software. So they really need to think about what is the right life cycle, software development life cycle to be able to build those kind of products, and they're going to need to shift a lot quicker. They're used to making cars on a 4 or 5, 6 year basis refresh, and software is on a day-to-day basis. There could be daily refreshes of software. So it's a very different mindset that they're going to have to change with, and we definitely are working with a lot of the OEMs on that challenge now.
Yeah, we've seen, we work with the OEMs a lot on this as well, and I think they can be successful at it. An underappreciated aspect, I think, of automotive software, that there really is automotive expertise involved with that. Oftentimes you hear the refrain that like, oh well, they can't build like a great software team, because like you have to go to like a Google or Facebook or an Apple to do that. But the fact of the matter is that there's some realities about automotive software that are unique to the automotive sector. And so I think they can leverage that expertise. You've also seen really good examples like Cariad being one of them at Volkswagen Group, where they basically ring-fenced the group, pulled in a bunch of talent from the various brands as well as from outside, and they're trying to sort of build a tech-forward enterprise that can serve the full group. And I think it's an innovative way of going about doing it.
Mike, from a consumer perspective, one of the challenges with having a fast rate of software updates is that there's a cost associated with that. It takes a lot of engineering time, a lot of validation to both develop and test it and then get it out there. How are you seeing, what are you seeing in terms of consumer attitudes towards being willing to pay for that?
Well, I think we can, turn to the Googles and Apples of the world and say that consumers have basically been trained to expect those updates for free. And even in the automotive space, Tesla has a reputation now of delivering not just updates, but upgrades for free. Of course, you can pay for, even higher upgrades, but essentially there is very little willingness among consumers to pay for updates unless they really see a tangible benefit. And even then, if somebody else offers the benefit for free or in exchange for user data or something like that, that tends to be where consumers tend to go. It's harder for them to conceptualize really sort of paying for an update because we just haven't really been trained to do that so far. So it's going to be a hard behavior to change from.
I disagree a little bit. I think that there's a balance between it, right? Because people are buying stuff on the Play Store all day long, right? So I think that there are going to be things where they expect it, absolutely, and they said this should come with my car. And then there's going to be other things where they're like, oh, that would be a cool feature to have. Like I would pay X amount for it. And the OEMs are going to have to figure out what that is and like what that level is, that threshold of what they're willing to pay for and when they're willing to pay for it.
Yeah, I completely agree. To the extent we're talking about, hey, here's a software update that needs validation, like the consumers look at that like, well, you should have figured that out the first time. If we're talking about new apps, new features and things, absolutely, there's definitely much more openness to that.
Well, we're almost out of time. I'd like to give each of you an opportunity to have a last word before we close up this one.
Yeah, I'll just throw in one thing. We talked about the data produced on the vehicle and the potential value. We're swimming in data on one side, and then we're lacking data on the other side about how to validate these technologies, right? So I think that's another piece that we have to solve is how do you get more data and make it publicly available so that people can validate these technologies and get them to market faster.
I was going to say this is like such an exciting time to be working in automotive. I think all the change that's going on is huge opportunity. So excited to be working in the industry.
Yeah, and just another trend that you highlighted a little bit, Sam, is that all of this capital that's gone into autonomous vehicles, the headline is that it's landed with a thud, but in fact, you're now seeing a lot of that redound back to ADAS in a really exciting way. And so I think the next 5 to 10 years are going to be, tremendous and sort of unrecognizable from a consumer's experience of the vehicle perspective from where it is today.
All right. And with that, I'm going to say thank you to my panel, Tarik Bolat from GPR, Phil Reich from Google, Mike Dovorany from Escalent, and Reuben Sarkar from the American Center for Mobility. And I'm Sam Abuelsamid, and thank you for sticking with us till the bitter end.